Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Thank you, Maitri. Let me get this. Okay. So as Maitri said, this is an attempt to talk about the R&D work that is going on in India, okay, in EECS. It's not really EECS, I would say, though I've used that word for shortage. I mean, primarily I'll focus on telecommunication, signal processing, and computer science. My area is telecommunication, wireless communication, signal processing. So I hope I do justice to the computer science community, though I'm risking myself by venturing into that domain. So let me start with the first slide. Okay, when Maitri called me, I mean, it's a pretty daunting task, trying to cover all that R&D work that goes on in India. Okay, so I had to sort of, narrow it down and make sure that the sample that I present today is something worthwhile and you get a good picture. Also, my talk is targeted a lot more towards people who are not living in India. Some of my colleagues who are from India are aware of what I'm going to say in one form or the other. Okay. So what I thought I'll give is provide some highlights. As Maitri put it, provide some kind of basically a sampling of what is going on. Okay. And when you try to cover such a huge canvas, one is always likely to miss out on something. Okay. So for my colleagues, whose work that I don't mention here, okay, I hope they will not hold it against me. So this is a quick picture about what is happening in India, and just it's a very complex. We have a very diverse culture out there, a very huge country. But those of you who don't live in India, and perhaps for those of you living in India also, quite often we don't have the statistics at hand. Okay, so it's a good idea to be aware of what we are now looking at. Okay, so of course what everybody knows out here is the population. We have over 1 billion people. Okay, but I mean it's managing 35 states and union territories. It's not a small thing. We have about more than 600,000 villages, at the same time more than about 6,000 cities and towns. So and some of the cities and towns are very well listed out here. What is also interesting to keep in mind is like the GDP of India, $650 billion. Not a earth-shattering figure when you're standing in the US and looking at this particular number. Okay, so if you look at the per capita income, it is 534. India's economy is ranked 120th if you look at it with respect to the per capita GDP. But what is very interesting is that the economy is ranked 4th if one were to consider PPP, that is purchasing power parity, and it is just behind US, China, and Japan. So in that sense, I think the broad GDP based thing is a misnomer, and many people who are living in India, who visit India, can see the difference, okay, as to what is happening. So this is what I wanted to highlight. Okay. Now, if you look at R&D organizations in India, it's a fairly complex structure which is there, a very vast structure also that is there. Of course, we have academic institutions, and I'll talk primarily about academic institutions. We have ISRO, that is Indian Space Research Organization. They do a lot of R&D work, and a lot of cutting-edge R&D work goes on out there, both in computer science as well as in communication, signal processing, image processing, a lot of other aspects. Okay. Okay, then we have DRDO, Defense Research and Development Organization. It has a large number of laboratories, okay, and they also do a lot of cutting edge research. In fact, some of the problems both in ISRO and DRDO are very, very challenging. Okay. Okay, then we have the third department, which also is very active in research, Department of Atomic Energy, like the BARC in Bombay, Bhabha Atomic Research Center. I mean, they do a lot of work in computer science, theoretical computer science, as well as a lot of work in developing specific computers for their needs, which in fact, of course, has some fallout in the real world. And of late, what we have had is industry interaction. This is perhaps, I would say, in all earnestness, the post-95 phenomena, and perhaps much more active since 2000. And there is always a strong interaction between the two. Okay. Academic institutions in India like IISc, IITs and all have very active interaction with ISRO, DRDO and Department of Atomic Energy. By and large, all IITs and IIScs have centers which are exclusively funded by at least one of these organizations. In many cases, all three have a presence out there. Okay. This, I put it in a dotted line simply because this is a new interaction which has started. This is at least a personal opinion, some may disagree, and it needs to be strengthened much more. Okay. The quantum of resources also that comes from industry is much, much smaller than the quantum of resources that come from here, and which should not be very surprising looking at what in the morning that Bill Gates and the dean from Princeton was talking about, that DARPA was the major source of funding at one time. Similarly here, DRDO is in fact the big source of funding, similarly ISRO and Department of Atomic Energy. Okay. Now, this is the most risky slide that I'm going to put up out here, so, take it as one man's opinion and not necessarily the opinion across. So we have several tiers of institutes, okay, so I'm going to sort of categorize them, and there is always a slight risk in it. So at the top tier, I've put institutes like TIFR, IISc, that is Tata Institute of Fundamental Research, Indian Institute of Science. Okay, there are 7 IITs today. Of course, the 5 older ones are much more dominant when it comes to R&D work. ISI Calcutta, okay, Indian Statistical Institute, one of the older institutes in the country and does very front-end research in computer science, and Institute of Math Science. It's a small, tiny place in Chennai, but they do extensively and excellent theoretical computer science research. Okay. What is also interesting out here is that these are pretty much government funded. Today, all of them are government funded, but these two were started by through industry, in the sense of private ownership. Tata's, whose name still resides with TIFR, okay, one of the biggest industrialists in the country, and even IISc was started by Tata's. And today in Bangalore city, if you say someone, I want to go to IISc, he may not know where to go, but when you say Tata Institute, he'll take you to the right place. So in a sense, as I said earlier, there was a certain partnership, but Tatas were unique. Not everybody is like Tatas. At the second tier I've put, and again, this is where the things, CDAC, though not an academic institution, they do run a lot of training programs, and therefore I've put CDAC out here. The ordering is not very critical. BITS Pilani, triple ITs, there are several triple ITs that have come up. These, there are different sort of expansions of this. Indian Institute of Information Technology, or it could be International Institute of Information Technology. Offline we can debate as to why these terminologies have come in. Okay, there are 2 of them, one in Hyderabad and Bangalore. The 2 of them are doing front-end research. In fact, I would say that I was just talking with a colleague of mine, Balaji, that the IITs and IISc need to wake up, because these institutes, the triple ITs which are coming up, are slowly putting a lot of pressure and in fact even stealing some of the faculty members who would have typically joined IISc or IITs. Okay. And then we have a very large network of other institutes. Okay, we have NITs, National Institute of Technologies. Okay, these are across, practically every state has one. Some of the newer states don't have, like Jharkhand and Chhattisgarh, but otherwise all the older states have an NIT. Okay. There are other triple ITs which have come up. I'm listing them separately simply because they do not necessarily have a strong postgraduate program. Okay, Hyderabad and Bangalore both have a strong postgraduate program. Okay, there are triple ITs in Allahabad, Ahmedabad. Some of them are privately funded. The one in Ahmedabad I've listed as triple IT, but it goes as the DAICT, Dhirubhai Ambani Institute of Information and Communication Technology. Okay, so another industrialist who has started this thing, the Ambanis. Okay, in fact, we have 3 big industrialists in the country, one of the Tatas, the Birlas and the Ambanis. So Ambanis also have started it. Birlas come in here, that is BITS Pilani, Birla Institute of Technology and Science. So Birlas also have started an institute. There is a smaller one, there are 2 brothers, so one of them is involved with Pilani, another is involved with BIT Mesra. Okay, both have postgraduate components. And there are other universities. Anna University has, in fact, the biotech department at Anna University is considered to be one of the best in the country today. Okay, I'm sure others are quickly catching up, and many private colleges are there. So this is like a rough sort of distribution of how the institutes are placed and how the engineering education takes place. Bulk of the research is done out here, but what I find is that slowly there are occasionally some papers coming from even this category here, which are very interesting. Sources of research funding, in some sense it relates to my earlier slide. So we have a large amount of money does come from MHRD, that is Ministry of Human Resource Development. In fact, IITs to an extent, IISc, some of the triple ITs, not all of them, like triple IT Allahabad, they all come under this ministry. So essentially that's the parent ministry, they give bulk of my resources, like my salary comes from MHRD. Okay. And in fact, it is somewhat akin, though not quite, I would say, like NSF. Whenever they give research fund, very few strings are attached. It's fairly open. And if you want to do blue sky research, you do get money from ministry. Then occasionally they have these so-called mission mode projects, thrust area projects. So like nanotechnology would be a thrust area today, and they will provide resources for carrying out research in nanotechnology. Okay. Then we have various science and technology division. A lot of us are very actively involved in one form or the other with DST and MICT, that is Department of Science and Technology, Ministry of Information and Communication Technology. By and large, the funding which comes from here is somewhat targeted. They do look at it that it should have maybe a prototype at the end of it. But on and off, they do support, if the case is strong, an absolutely blue sky research. Okay. So these are other two main organizations from where one can get sizable funding. And what I mentioned earlier, DRDO, this is by and large targeted. But what happens quite often is that the problems they give are very challenging. In the process, you can get a lot of theoretical results also. But eventually they want to look at something that you develop which the defense can use. Okay. ISRO, the same thing. Okay. That is Indian Space Research Organization. Department of Atomic Energy, the same thing. In fact, they have this whole, I should mention DRDO has this new wing called NRB, Naval Research Board, something akin to what Bill Gates was saying, the small prints in Office of Naval Research, something like that, which in fact encourages blue sky research. So they will entertain proposals which are primarily for blue sky research. Okay, Atomic Energy has this BRNS, that is a research board out there. Industry support is also there. Okay. Industry support, as I mentioned, I think the quantum has to go up. I think that right now it is there, but the quantums are too small, and compared to perhaps the kind of support that industry gives to academia in the US, this is minuscule. Okay. Now, what I thought is, at this particular point, let me get into the R&D part of it, and again, this is another couple of risky slides out here. I thought, let me cull out two things, which have been done in India, which have had a worldwide impact. Okay. It is not an easy job. Okay, and in fact, I was able to find two things, by and large of recent development. The first one is Manindra Agarwal, the CSE department at IIT Kanpur. Okay, and this is something which has been, at least he has received various awards and from various societies in the US. What he discovered was a polynomial time deterministic algorithm to test if an input number is prime or not. Basically, polynomial time primality. Okay, this has been a long standing problem in theoretical computer science. And what is amazing is that the paper is about 8-9 pages long. It is not a very complicated proof, and he uses some very basic number theoretic ideas out there. In fact, if you look at my first slide, I had a small thing at the bottom, which is essentially just a cutout from one of his papers. Okay. Now, this particular work, also it was done with 2 B.Tech students. Okay, so it was all kind of homegrown research. Okay, none of this where we had collaboration with a professor or at Stanford or MIT, things like that. And he has received a lot of accolades worldwide. Okay. And what is also interesting that both these B.Tech students, rather than migrating to US for their PhDs, are continuing for their PhD at IIT Kanpur. Okay. Another one which I'd like to mention, this is not in theoretical computer science or in terms of theory, but more in terms of product development. So this is how academia interacts with products. There is a group headed by my friend Ashok Jhunjhunwala, okay, and they had developed this wireless in the local loop technology. Essentially taking the DEC technology for cordless telephony and extending it, which can be used for rural internet kiosks. Along with that, this basically gives a very inexpensive pipe. Okay, it has been in fact deployed at various villages in India. They have also marketed it. They have incubated companies, and through the company they have marketed it to Africa, Middle East, and some of the other developing nations. Recently, what they have developed is, I don't have time to talk about it. I just mentioned so-called a rural ATM. For example, a typical ATM would cost something close to about $20,000. While the cost of this ATM is approximately $1,000. Of course, the functionalities are reduced out here. They are not major functionalities, but it is primarily targeted for serving the rural population. The reason I'm mentioning is that I was involved in developing this fingerprint authentication system, and the total cost of this, if you exclude the software, is no more than 50 rupees. It uses a webcam, okay, and a small lens that we normally would use in high school experiments in physics. Let me look at, say, the R&D vision of an academic institution, be it IITs, IISc, some of the triple ITs that I mentioned. By and large, they all have a very, I have tried to sort of take a common denominator out there. Most of them will talk about leadership in research and development. About 10 years ago, R&D, even IITs were not as active in research. Though I am from IIT, I have to humbly accept that. ISC and TIFR were the leading research institutes. But over the last decade, little more than that, IITs have really become very active in research in the sense that you cannot get your promotion unless you have publications. I mean, that has become like a mandatory thing. Oh, I have 5 minutes. Goodness gracious. Okay. So maybe I'll just quickly then run through this. Okay. So this is the usual, we work on theoretical problems, publications, incubate companies, partnership with industry, and also look at technology development. Okay. So I'll skip some in-between things, since I have only 5 minutes left. Okay. And this is a new dimension which has come in. And I'll have one slide where I talk a little bit about this particular part, which was not there. This is, I think, the post-IT boom. That this notion of incubating companies, practically all IITs have certain societies that they have formed, which will enable incubating companies. Okay. Now, I want to just kind of briefly give this picture out here as to what are the kind of expenditures that are involved in R&D. If you look at US, okay, and we look at, say, the number of top 1% of cited papers. We're not looking at all of them. Okay, there are a large number of papers we publish. Some of them get cited, and that too you look at the top 1%. The real, what one would call, quote unquote, the exceptional papers. USA has approximately about 23,000, say 24,000 papers a year. China about 375, India 205. The amount of money that is spent out here per capita, US spends about $700 per capita expenditure on R&D. China about $12, India about $5.50. Okay. If you look at expenditure per top cited paper, this is an interesting figure. It's $8.4 million for US. Okay, you multiply this with the population of the US and then divide by this particular number out here. Okay, that's what you'll get. It's a fairly big sum, I mean, if you look at it. And for that matter, India is not too far behind, $2.7 million per. See, we are talking of top-notch papers. Okay, it is not cheap to be cited in the first or the top 1% of the published papers. Okay. Expenditure per scientist in US, it's about $230,000. China, $16,000. India, about $35,000. Okay. Scientists per million, this is a generic thing. I'm not talking about only engineering or only CS and E. It's very difficult for me to, I was not able to get that data, but I got the data for essentially science and engineering education. Okay, so if you look at, say, scientists per million, USA has close to about 4,000 and much smaller population. China, I was unable to get the figure. India has about 157. And given India's population, it's like 157 per million. Okay. So if you multiply by, to get by 100, you will get a reasonably good number. So we do have reasonably good number of scientists. The cost of doing research also is much less. Okay. And this sort of indicates as to how the R&Ds are balanced out. Okay. Now, I'm not going to talk about details of each of this, but I won't get into it. I mean, if you look at, say, communication and electronics, practically any topic that you think of is pursued at least one of the IITs, in most cases, at least for a large number of IITs and IISc. Every leading institute pursues most of these topics, or at least a major number of these topics. And I mean, broadly, if you look at, this is a generic topic, signal processing, wireless communication, communication networks, next generation wireless, ultra-wideband communication, optical communication, space-time processing, information theory and coding, nanotechnology, network security, almost everything is covered. Of course, I've deliberately put this as a puzzle because we do not necessarily dovetail very well. Okay, and the same thing is true, I find, in the US, and everybody works in their own island and hopes that somewhere somebody else will put it together. Okay. Computer science and engineering, same sort of thing. Any area you think of in CS, okay, computer science and engineering out here, it is covered at IISCs or TIFRs or IITs. Okay, mobile computing, ad hoc networks, language technologies, a lot of work goes on. In fact, IIIT Hyderabad, I would say, is perhaps the leader when it comes to language technologies. Okay, bioinformatics, machine translation, machine learning, all of this, and off late grid computing. Professor Raghavan is there. He's been leading this particular activity at IIT Madras. Okay. Now, I'll skip this particular part. I had a little bit of description on each of these things, on the various things that are going on, since there is a shortage of time. Okay. The product development, what I was talking about earlier, I just gave one example of what was done at IIT Madras. Now, if you look at it, all IITs have something or the other. Okay. They all have business incubators, and they go under different names. For example, IIT Madras, there is no formal business incubator, but people can facilitate. And Junjunwala has been able to incubate something like 14 companies. IISc has something called SIT, Society for Innovation and Development. IIT Kharagpur has STEP. IIT Delhi has FIST, IIT Bombay has SIGN, IIT Kanpur has the SIDBI Innovation and Incubation Center, okay, and similarly other IITs. So it has become like an in thing. The whole idea is that sometimes some of these are what we will call Section 25 companies. These are non-profit companies. They are the ones who will own some percentage of the company which is incubated by IISc or IITs, etc. Some of the products that have come out, okay, this is again a very partial list of it. Simputer, which came out of IISc, and many might have heard about it. Param Computer, in fact, came out of CDAC. Okay. Though CDAC actually has a mandate to have products. It is not necessarily that they have to do only theoretical work out here. This is basically, quote unquote, India's answer to supercomputer. Cordec from IITM, Rural ATM. A lot of work has come out on Indian language software tools and packages, particularly from CDAC and some of the smaller sort of companies like Chennai Kavigal and others. And there are many other products out here. I don't have enough time to get into all of them. This is again just giving some numbers out here. I'll take a few minutes, So if you look at intake in engineering, today there are approximately, say, 10 million students who are enrolled. It's also sort of not a very, when I think of a billion population, of course not all of them are students, but about 10 million students are enrolled. Okay, out of which engineering intake is about 692,000, say 700,000 today. Okay. And what is perhaps interesting is just look at the number of PhDs. Overall, we produce 739 PhDs. This is net physics, chemistry, mathematics, electrical engineering, civil engineering, mechanical, computer science. It's not a very, very healthy number if you want to enhance academic institutions within the nation. Higher education, India spends approximately about 0.4, maybe it goes up and down depending on the economy, maybe it might be 0.6 now. I think if I'm not mistaken, USA is about 1.5 or 2% of the GDP. Okay. These are some numbers on publications, number of faculty, computer science and engineering, we have about 250, 275. Number of PhDs, maybe 30, some may say 50. It is really not a number to sort of be very happy about. We do have a large number of M.Techs that are produced, and they do provide the main manpower for all the companies in Bangalore come from the M.Techs that are there. Communication and signal processing, the numbers are larger simply because the number of faculty is much higher out here. Okay, so it's somewhat proportional to that. If you look at the publications, there are about 150 international journal publications, international conference publications, about 300 in computer science. In communication and signal processing, again more, 300 and 400, simply because we have more people, more manpower out there. Now here I've listed, the numbers are rather small. There are lots of conferences which are held in India. Okay, local ones. Sometimes we add the word national, international, etc., and they are one-off conferences or once in 5 years. But if you look at the leading ones that are there, computer science has about three or four. High PC is one. Then this theoretical foundations of computer science, that is there. There are two which are there. These are two international conferences. Large number of national conferences are there. Similarly, if you look at signal processing and microelectronics, about 4 or 5 national conferences, major ones, and about maybe about 3 to 5. 5 is a good number. Typically, it's about 2 to 3 really world-class international conferences. I'm talking about IEEE conferences which we bid for and hosted in India. Okay. I'd like to end with just wrap up with a couple of quotes. When this GE Center was started in India, John F. Welch had this very interesting statement. He says, India is a developing country, but it is a developed country as far as its intellectual infrastructure is concerned. We get the highest intellectual capital per dollar. Okay. In fact, so what you find today, many multinationals, which includes Microsoft, Motorola, Lucent, Google, IBM, TI, Analog Devices, Philips, Sony, Ericsson, HP, Intel, Nokia, and many others, they all have R&D centers now in India. Bulk of them are in Bangalore. Okay. And these are over and above the development centers that they have. So that is separate. So I'm talking about R&D centers. A lot of R&D work is being carried out at these centers in India. Okay. And finally, I'd like to conclude. There is this famous statement from one physics Nobel laureate. I hope I pronounced it correctly, Riccardo Giacconi. I'll just read it out. A scientist is like a painter. Michelangelo became a great artist because he had been given a wall to paint. My wall was given to me by the United States, and he did very well. So the way I look at it is that now such walls are emerging in India, and what we are seeing is a ray of reverse migration, to paint these walls and do R&D work in India. Okay, many thanks. So any questions? So, what do we do?
Thank you very much, Uday. That was really nice. I wish we had more time, but I'll ask Dr. Srikant now.
Yeah.
He'll be talking about compiler research in India.
Thank you very much, Maitreyi, and I thank Microsoft for an opportunity to speak here at the Faculty Summit. So where do I? Here. This is okay. Is this functional? Okay. Right. Good. Thank you. So I'm going to be much more focused in my presentation than my colleague. So principally, I'm going to concentrate on the research work that has been carried out at the Indian Institute of Science in the area of compiler design. If we look at the past, for information, about 25 years have gone by in the research in compiler design at the Indian Institute of Science. And in the past 15 years, here is a very selected list of projects, topics that we have been looking at. So we looked at way back in 89, 90, we were looking at the automatic generation of incremental parsers, semantic analyzers, and then in 95 or so, we looked at an optimizer generator, which would take as input the description of optimizations and generate an optimizer from it. Then machine code generation research has been going on for almost 20 years now. To begin with, it was with top-down tree pattern matching, and we progressed to other forms later. We'll see that in a little while. And in 97, 98, there was a brand new algorithm for partial redundancy elimination, whose proof was extremely simple to what existed in literature. Automatic parallelization, again, the research has been going on for about 20 years. So we built compilers for shared memory machines, and then parallelizing compilers for distributed memory machines. And of late, about 5 years ago, there was a PhD thesis which looked at the automatic data partitioning problem using genetic algorithms. So now, coming to the research that we are doing today, last year, this year, and maybe the next 2-3 years, we are looking at code generators from a new perspective, instruction scheduling, power-aware compilation, and just-in-time compilation. So in the area of code generators, my colleague Preeti Shankar, she has been looking at the issues of tree pattern matching from a new angle, which is based on LR parsing. So this is something which appeared as a very significant paper. And then this approach has been integrated into the Trimaran compiler infrastructure, which is a public domain, very well-known compiler infrastructure, and it uses the L code, intermediate code as well. It has been tried out on the Texas Instruments DSP process and also the Itanium process, and of course the results are very encouraging. And then the work on instruction scheduling is quite extensive. There are 3 of us, my colleague Govindrajan, Preeti Shankar, and myself, who work in these areas. So the topics at this time we look at are the VLIW and superscalar architectures, especially an approach which is based on integer linear programming for scheduling, and then how exactly does one balance between hardware and software pipelines, how to schedule them so that there is an optimal output possible. So this is something which is going on. Again, continuing on that, more recently, clustered DSP architectures have become very popular, especially the most recent is the Texas Instruments chip. And when it comes to the instruction scheduling on these clustered architectures, there is a serious problem, because you either have to assign programs to clusters and then schedule them, or you schedule them and then assign the clusters and then somehow patch up. These were the two approaches which were being used. So the integrated scheduling, which became popular a few years ago, is something we took further to clustering as well. So now our algorithm, there are two versions. One uses heuristics for ordering the instructions, and the other uses graph matching. It combines both clustering and instruction scheduling within the same algorithm. So it is not in two phases. These algorithms have been integrated into the Stanford University Intermediate Format Compiler framework, and our experiments with the Texas Instruments chip especially have been very encouraging. Power-aware compilation is something we are looking at more recently, and as everybody knows, the transitions within the CPUs, the function units of CPUs can be switched on and off based on their activity, and these transitions also cost power. So if we are able to minimize the number of transitions from active to low power and vice versa, there is obviously saving in energy. So we have been able to come up with a new algorithm which minimizes the number of transitions and essentially stretches the busy periods and the idle periods as well. The experiments have been with the Xscale architecture and then the Xtrem simulator which is available for it, and we modified the GCC to generate code for it. And the other issue that concerns power and compilers is the interconnection between clusters in a clustered architecture. So until now, the interconnections which have been provided between clusters in clustered architectures have been of the same variety, in the sense they were optimized for speed to give you the best possible performance. But now, because of the power gaining an upper hand, people have been proposing different kinds of buses within CPUs. So one could be with a high power and high speed, and the other one could be with the low power and low speed. But now the difficulty is in how does one come up with a good instruction schedule in order to run programs, not only with a good performance but also with lots of saving of power. So our experiments have been with the trimaran infrastructure. We had to modify this trimaran infrastructure substantially in order to generate the simulators and things like that. So again, continuing with the power-aware compilation topic, the data cache, when it is actually partitioned into two parts, let's say the general purpose data cache and what is known as an object cache, seems to actually give us a lot more benefit, not only by way of performance but also power. So the difficulty actually is in trying to come up with strategies for how to partition the cache, how much of it should become the data cache and how much of it should be the object cache for applications. So we use static analysis, profiling, etc. to classify objects as long living and short living. Long living objects perhaps just go to the general purpose cache, or it could even have a hierarchy of object caches. These are all the things that we are trying to experiment with at this point. And we are also looking at design of a framework for writing power-aware applications for the ECOS operating system, which is an operating system for embedded applications. So the idea is to come up with hooks into the operating system so that when a person writes a power-aware application, the programmer is aware of how exactly the application would fit into the operating system itself. So that's an issue which is not trivial, and the project has just begun. So really we have no idea of what exactly is needed. Then we do a substantial amount of work in just-in-time compilation, and one of the major projects that we have completed recently is an efficient JIT compiler for the .NET Common Language Intermediate Code on the Rotor framework. So Rotor is, as is well known, is the open source distribution for .NET, and we incorporated various profile guided optimizations into this JIT compiler, and we recently incorporated a very efficient concurrent garbage collector which works on the principle of what is known as cluster and collect. Basically, there are data structures in every program which are very long living. We can call them as immortal objects. We use profiling and static analysis in order to detect these long living objects, and we don't want to actually put them into the same heap and make the garbage collector copy the same objects over and over again. So these objects are put into a separate space called the mature object space, and we also use stack allocation for scoped objects so that the object itself gets collected when the function returns from its activation. So these are the two schemes for garbage collection time improvement, performance improvement that we have incorporated into our garbage collector scheme. We also when we were looking at the profile guided optimization, it became very clear to us that unless profiling itself takes less time, there is no hope for the profile guided optimizations to work with great benefit. So because of that, we started looking at the architectural innovations which are needed in order to speed up profile collection. So very recently we did some work on a hardware scheme which enables us to collect profiles in a very, very fast manner without too much of hardware real estate as such. So, and this was programmable in the sense it could actually accommodate different kinds of profiling. So, and incidentally, the student who worked on this is currently doing an internship here. So that's about it. That's an overview of compiler research at the Indian Institute of Science, and thank you.
Thank you, Dr. Srikant. We'll have Dr. Gupta from the Indian Institute of Technology, Kharagpur, talk next.
Thank you, Maitri. So we have had two good talks of very different nature. Professor Desai's talk was on the overall research scenario in India, and Professor Srikant's talk was very focused research at Indian Institute of Science. So I'm going to be in the middle. I'm going to talk about the research in my institute, but it's going to be more broad-based, and I'm going to try to give you an idea about the type of things that we do at IIT Kharagpur. With the time that I have, I'm afraid that's just going to be a glimpse of what we do. But my goal here is not to go into too much details about anything, but just to give you a flavor of the variety of things that we do out here at IIT Kharagpur, and which is kind of representative of what happens in other IITs as well. So let's start with, just to put everything in perspective, the profile of our department at IIT Kharagpur. Kharagpur, by the way, is the oldest and the largest in terms of the number of students and the number of departments among the 7 IITs out there right now. And most of the CS related research in IIT Kharagpur happens in Department of Computer Science and Engineering and the School of IT, which was formed about 3 years back. There is some amount of research that also happens, related research that also happens in the Department of Electronics, but I'm not going to go into that. So together we are around 25 faculty. I say around because 1 or 2 of them are always out of town. Around 40 research projects that are sponsored usually by government organizations and industry, both in India and abroad, mostly from US. We have around 250 undergraduate students, which are all in CSE department. The difference between a department and a school in IIT Kharagpur is a department offers both undergraduate and postgraduate degrees. A school does not have to offer an undergraduate degree. That's only Kharagpur specific. We have about 70 M.Tech students, which is similar to an MS degree out here. It's 1 year of coursework and 1 year of thesis. And we have around 40 PhD students and 40 MS by research, which is an MS degree. It's a postgraduate degree, but it's more research oriented and much less coursework than the M.Tech degree. Plus we have other project staff who are just project staff but not enrolled in any particular project. Research area wise, we work in a lot of areas. As I said, as Professor Desai has also said, that almost all IITs have a large number of areas in which the faculty works in. I have mentioned some of the major ones, and my classification for something to be termed as major is if more than one faculty and a group of at least 5 graduate students around them are working in a particular area. We do have faculties, who work in only one faculty working in one area and so on. So these are kind of some of the areas we work on. Formal verification, we have a very strong group. Real estate design CAD tools. Security, we work on almost all aspects of security, starting from cryptographic algorithms, script analysis, all the way to like database security, OS hardening and stuff like that. Embedded systems, multimedia systems, all the standard stuff. The last 3 are kind of special because they are kind of very application oriented areas which involves research in some of the multiples of the other core areas out there. Most of the work that we do happens in these labs out there, and since this Microsoft Research Faculty Summit, I'm going to talk about the projects, some of the projects that we do in those 2 underlined labs out there, because those are the labs which actually use a lot of Microsoft technology. Not necessarily we do research on Microsoft technology, but we do research using a lot of Microsoft technology. But these are some of the other labs that we have out there which are kind of focused on particular research areas. So the Communication Empowerment Lab, which is originally was a Media Lab Asia hub out there, is still funded mostly by Media Lab Asia, but it's also funded by other government agencies. And it's kind of a special lab where we develop technologies for different things, and the current focus is firstly building augmentative systems for people with disabilities. So I'm going to talk about one project, give an example of a project that actually does this. And the goal, that's one area. The other area is where we want to take information technology to the masses, and the area that we focus on right now is education for rural schools. And again, I'm going to talk about one example projects in that area as I go on. And the third part is important, that we don't do these things just for doing research, supporting students, publishing papers and all these things. That's one of the things that we do also. But focus is on vernacular and multilingual communication, social realities and culture. We actually go out on the field, we actually deploy these systems, we actually use these systems, continuously collect feedbacks, improve the systems, go back to the field and do things kind of like that. Microsoft Lab, on the other hand, was kind of an open-ended project from Microsoft, set up in end 2001. We actually started working in early 2002, to be precise, with a grant from Microsoft. It's still continuing. And the goals were initially to create Windows infrastructure in the department, promote the use of Microsoft technologies in student projects and faculty research, and initiate collaborative research with Microsoft. I want to stress that this is not really kind of a courseware kind of lab. It's a small lab with around 12-13 machines where we selectively do some faculty and student research projects. Though it has been kind of acting as a catalyst in building up the overall Windows infrastructure in the department as well. And we have done so far about 50 projects, which includes both research kind of projects as well as system development kind of projects using Microsoft technologies. So what I'm going to do is just take a few projects that we do out there and talk very briefly about them, maybe 1 or 2 slides each, just to give you an idea about what kind of work we do in those 2 labs. And if you have any further questions, you need more details, I'll be very happy to talk to you later on. So first project I'm going to talk about is something called the mobile telemedicine systems. Telemedicine, actually we have kind of a long experience. We have been working in this field for about 7-8 years. And before we started this mobile telemedicine system, we already have a system called Telemedic, which is a full functional telemedicine system. And the purpose was to link up the city government hospitals with district and sub-district level hospitals, and to provide medical expertise from city hospitals onto the district hospitals and sub-district hospitals, where not that much medical expertise was available. And the important things when we started was to develop a full functional system which can do everything that normal telemedicine system can do, but using low bandwidth noisy links, because most of these sub-district and district hospitals used to be connected using phone links, which used to be very, very noisy. So we did a lot of research in those areas. Right now, we actually field tested it in a couple of hospitals for nearly 3 years, collected a lot of feedbacks. And right now, we have MOUs with 2 state governments in India, West Bengal, where the state that we are situated in, and Tripura, which is the other major state in northeastern India. So the system is already installed at 6 hospitals and being installed at 12 others in these 2 states. So during the course of this work, we interact with a lot of doctors. And what we found from the doctors is that many of these city-based doctors are actually extremely busy. And they are affiliated with a lot of hospitals. They are not just affiliated with one single hospital. So they actually hop from hospital to hospital, clinic to clinic throughout the day. And they had this need that they told us that if I'm in one hospital and I have a patient in another hospital who undergoes an emergency, and then somebody calls up, they page him or call him on the cell phone and ask for advice as to what to do, usually the kind of information that they have access to is only like textual information that can ask over the phone and all. So basically their need was to have some sort of a system which can give something more than just plain text information or audio information that they can ask somebody over the phone. So this is a telemedicine system, is a telemedicine application on PDAs cell phones for doctors on the move. Integration of text and image transmission of wireless links, and the main challenges in doing this is basically all the standard challenges of building something on PDAs or cell phones. The primary one that we faced was challenges posed by small display area. For example, how do you show an ECG in a small display like that? And I'm going to show you an example shortly. And then the other things, limited computational power and memory power constraints, because many of these, showing this, especially the graphical data, requires a lot of image processing things in telemedicine applications. So we had a client-server model where the doctor can ask for different information, and you can actually do the image processing on the server and actually transfer it very fast over the wireless links to the PDAs. So I'm just going to show a very short example. So this is how we, this is one shot of how we show an ECG. So ECG actually, if you know it, is like 12 leads. So each lead generating a waveform, and then each waveform has certain meaning to assign to it. So this 12 leads are kind of independent. So we show it lead by lead. That's just one way of seeing it. You can also see the entire thing, and you can move just a pen in any direction over this, in certain direction, like vertical, horizontal, and certain angular directions, and you can actually traverse the entire ECG out there. And then you may want to get some information out of the ECG that requires certain computations, and then you can ask for that, and that gets done at the server, and the result comes back to you on the client pretty fast. So that's about telemedicine. We do a lot of other things on telemedicine actually. This is a project that we have just started. So this is part of a multi-year project funded by Government of India on building what we call resilient systems. So the aim is for this particular thing is to create a database capable of restoring its consistency even after being compromised. So one aspect of this work that I'm not talking about here at all is intrusion detection. We do research in intrusion detection, and then this part deals with how do we recover a database after we have detected a malicious transaction. And there are a lot of other works on that, but most of those works are basically mainly based on this notion of compensating action re-execution. You don't want to rebuild that database completely again, so you kind of try to form dependency among what transactions later on are dependent on the malicious transactions, and then you want to apply compensating transactions to actually offset certain effects and re-execute some of the proper transactions out there. And our contribution so far on this area is to propose new transaction dependencies that improve on the existing schemes. Basically, we show that certain dependencies between transactions cannot be captured by the existing schemes, but that can be captured by our schemes. And one of the things that there's in almost all our works out here in both the Microsoft lab and the Communication Empowerment lab is it's very, very application oriented. We want to build systems. We want to think things in action. So we have a prototype system that is built around SQL Server 2000. It's basically a wrapper around that is going to intercept the queries and actually do certain tricks so that if you do detect a malicious transaction later on, recovery becomes pretty fast. Of course, your normal operation becomes kind of slow, so we're still working on that. And as I said, this is part of a multi-year project that was started I think end of last year, funded by Government of India on building resilient systems. So we hope to get much better results in the next 2-3 years. The third one is something that is my favorite, because I have had chance to actually interact with people that person. This is called Sanjog, and this is work that we do jointly between Communication Empowerment Lab and Microsoft Lab in building an alternative communication aid for people with speech impairment and neuromotor disorders. So these are people, I want to stress, who do not really have control over their movements that much. So they can move their hands, but if you ask them to put their fingers right on here, they may not be able to do that. So they're going to move their hands, going to fall here or fall here, something like that. But I want to stress this. This is a wrong notion that a lot of people have out there. I don't mean you, I'm sorry. Is that these are not necessarily people with less cognitive abilities. So we have actually worked with people who have very little control over the movement of their hands and all, but who can write great poetry, who can write great short stories. We've actually worked with people like that. So before we say what we do, you have to understand their manner of so-called speaking. So now what they do is they have this huge board out there in which there are lots of pictures, and this person with neuromotor disorder actually moves their hands and try to point at the different pictures in sequence. And you have to have a trained person sitting on the other side of the board who is going to make sense out of what they are trying to say. So these are persons with special training who are actually going to make a sentence out of, let's put that way, make an English sentence out of the sequence of pictures that this person has pointed at. Problem with this approach is obvious. You need lots of boards, first of all. And the second thing is you need, that's the most important thing, a very trained person at the other side. And those persons are very, very, not very easy to find. So what we do is we build a system with a visual iconic language based, so similar to the board, can be personalized to the cognitive ability of the user, and it has an alternative access mechanism because these people cannot really use the mouse or the keyboard. Their motions are not that fine-grained so that they can actually click on a particular key on the keyboard. I'll just give you some examples. So here is 3 snapshots of the system. This is actually in Bengali, which is the predominant language in the state that we work on. But basically what they are saying is this, that I can have, depending on the amount of flexibility that I want to communicate, I can have different interfaces. The one on the top is the simplest one to use. So basically it's a vocabulary of sentences, complete sentences. So usually some of these people have very little cognitive ability, and all they want to say is normal things like, I want to eat, I'm tired, I want to go to the bathroom, and things like that. So we actually work with a lot of these children out there, see what their needs are, what kind of sentences do they normally require. And we build a vocabulary of sentences. So if you don't want any further flexibility, you can just go there, choose from a set of sentences, and it will say that. The one on the bottom is at the other extreme, which is complete flexibility. It's like a keyboard that you can use. One out here is the kind of interesting thing, where you have an iconic language things, and design of the icons, how you present them itself is a big research issue out there. And then you can select certain icons, and then you can select certain language specific things like, what tense do you want, okay, whether you want a positive statement or negative statement, things like that. And it's automatically going to form a sentence out of that thing. And we actually have a text to speech Indian language interface along with that, which is going to say it out also if you want it. So these are kind of, you get different flexibilities based on different cognitive abilities that you have, can be preset, can be chosen dynamically also. And this thing actually can do a lot more than the simple screen, what the simple screen shows. So it's just an example, similar thing out there. And here is the access mechanism, which is pretty simple actually. So basically what happens is you show these options on the screen, all these icons or whatever options you want, and you have a scanning mechanism which just scans through these things, and you can set the time that it stops at each of the icons. And there are these 2 big switches that we developed that are just sitting out there. So all the person has to do is to bang on the switch, and that particular thing gets selected. Very, very simple mechanism. Yeah. 5 minutes? Okay. It supports 3 languages, Bengali, Hindi, and English. As I said, Bengali is the predominant language in the area that we work in. And it has already been deployed at 4 centers. Indian Institute of Cerebral Palsy, Manovikas Kendra, Kolkata, 2 of the premier centers in Eastern India for this kind of people. And we have also developed it in Ahmedabad and New Delhi. The cerebral palsy, actually we have developed it for more than 2 years, so we get most of our feedback from that center. Okay, we are just starting to get feedback from the other centers right now. And just as I mentioned, this is winner of the Da Vinci Award, which is an award given worldwide by Engineering Society of Detroit and Multiple Sclerosis Society earlier this year. So I have little time left, so I'm going to talk about one more project shortly. I'm probably going to skip the 5th one. Samvida was the other one that I talked about, excuse me. And its goal is to provide low-cost internet access to rural schools. And the main problem with these rural schools is that The only means of communication usually is dial-up phone lines, noisy lines. More importantly, most of them cannot afford the cost of long connections. So how do you make their children actually, students actually browse the internet, get relevant information out of the internet and all? So what we have, the model, the overall model that we have is a very, very simple thing. It's an offline access. So students give their queries to a local server. So suppose you want to do Google search, you give your queries to go local server. The local server is going to pack it in an email and send it to a central server. So only connection that you need for the uploading is this connection from this local server to central server for sending the queries. And the central server is going to actually do Google search, browse the web pages, all these things, package the thing nicely and send it back to you. And then again, you can look at it offline whenever you want it. However, we do have a lot of different things inbuilt out there. So we have ontology-based filtering of web contents. And we actually have ontology editor also, for example, for you to actually create the ontology. So we don't just, when you search in Google, all of you know this, then you get a bunch of pages. So which pages do you download, which pages do you see? So we have ontology-based filtering mechanism to find out the relevant things. We do user modeling, which can be based on user inputs, but we have a learning mechanism to learn the user profiles from browsing patterns. For example, if you're doing physics, okay, what are the things that you normally look for? Similarly, we do ontology-guided navigation search from the locally built repository. So over the time, as you access more and more things over the net, your local computer system keeps on caching those things internally and your repository builds up. So all the time you don't need to actually go out on the internet. Like everything else is vernacular based, so it's not English. It is English, but we have other languages as well, that's what I meant. And this is mostly pilot deployment in 4 schools so far. So we have worked with one school, actually one big school in West Bengal. We got a lot of feedback from them. Based on the feedback, we changed the system, and right now it's in pilot deployment in 4 schools. I have a couple of minutes. I don't have much to say, so I'm just going to say one slide about this project, other thing that we do. This is kind of a mature project that we talk about, if you want to browse web pages from PDAs, what do you do? Main problem is a small display area. You cannot really show, if you look at the page, this is what it comes out to be. So you don't really want to see it like this. So there are different approaches for doing that. One approach is, lots of people use it, is manual reauthoring. So you have 2 versions of the page, one for the desktop version, one for the PDF version. You have other approaches are semi-automatic, which are like annotation based. So you do give some hints for the proxy to actually annotate things, to transcode things. Or you have complete automatic schemes where you have no hints, nothing. You just take a web page and you try to, reauthor the web page to fit it nicely in a PDA. So we do automatic reauthoring. We present only relevant information categories in the predefined domains, domain-specific categories. And this 4th point is the interesting point. So we do this based on just the visual information available on the page. So it's not something that's going to work very well for general domains, but it's something that works pretty well for very constrained domains. And mostly for kind of domains that, statistics show that people browse a lot from PDAs, like news, stocks, emails, small searches and things like that. Those pages usually have a nice structure to it, and you can actually use the structure and the visual information out there, like the font and the color and the positioning of the different things, to actually very nicely show what happens. So here are some examples. So this kind of newspaper pages we first categorize into top level categories like headlines, sports, international news, national news and so on. You can actually click on any of them to see things below them. You can actually click on, actually slide things left to right to see some snippet of the story, and if you want to read the entire story, which may be long, you can actually again slide it on the top of that to see these things. And as I said again, we don't claim that this is a technique that works very well for all general domains, but this is a technique that works pretty well for many domains that are browsed heavily from PDAs. Oops. So these kind of representative projects in only these 2 labs, I've just listed some of the other current projects that were ongoing out there. So we are working on different types of architectures for delivery of software as a service. We do work on mobile agents, especially the specific thing that we are working on right now is a middleware for automatic code generation from high-level specifications, so that somebody who is not used to agent programming at all can still build mobile agent-based distributed applications. We have a whole set of works on tools for extensible processor embedded systems, which include simulator generators, generators for compilers, assembler, design-specific exploration, power optimized compilation for embedded systems. We did a lot of work for defense and ISRO actually on ASIC design, specific ASIC designs. We have projects on modeling and management of multimedia objects for content-based search in multimedia databases, personalized information retrieval, cryptography schemes, and all these other things out there. So I am running out of time, but if you need any more details of any of these projects, some of them I know I should be able to give you, and the others I should be able to point you out to relevant faculty if you need more details. So if you need more details, go to our website or just send me a mail, talk to me, whatever. Thank you very much.
Thank you, Dr. Gupta. So we have 15 minutes for Q&A. So if any of you have questions for the speakers, we can take those now.
This is for Dr. Gupta and also Dr. Desai. You mentioned about network security. What level of detail you are doing there in the security aspects there for the wired systems and wireless?
You want to take it first? Or?
No, I think both the levels, there is a major initiative from the government, and major projects have been given to various IITs and IIC. There is one nodal institute, I don't remember which one is the nodal institute, to look at network security, both wired as well as wireless. I think mainly looking at cryptography, that's one very big problem. Then I have some colleagues who do theoretical research. For example, a colleague of mine looks at elliptic curves. That's a new one. By and large, all the security that is based on RSA. Okay, the public-private key system that is there, as opposed to RSA's algorithm. Nowadays, the new algorithms which are coming up are using based on elliptic curves. So you can get the same level of security with much less number of bits. So for example, 256-bit elliptic curve security would give you the same level as maybe 1024 RSA key.
Not just the cryptographic aspects. What about the intrusion aspects? Because that is becoming a major problem because routers and others are getting compromised.
Yeah, I think that as part of the major initiative, that problem, that issue is definitely there. Yes.
I think overall, as Professor Desai has said, the government initiative that we see is to build secure systems, wired, wireless, everything. What we work on is a part of that. So our work focuses on cryptographic schemes, elliptical curve cryptography included, for wired network as well as for wireless networks. Intrusion detection, we are mostly focusing on database intrusion detection right now. Okay, so we don't really do work on, for example, router intrusion detection, things like that right now.
I must add that two of my colleagues, one Dr. Bhattacharya, he looks at machine learning techniques for intrusion detection at the Indian Institute of Science.
I just want to add that there's a recent initiative by a department in the government, which is looking at putting in about 80 crore, that's 800 million rupees over a 5-year period for education in information security. So this is going to be spread around 8 to 10 the top level institutions plus about 80 others. 9 plus 35. So it's a fairly big program that they're trying to put into place sensitivity right at the curricular level to information security, that's operating systems, network security, cryptography. I myself have done some analysis on protocol analysis, correctness of security protocols. So there's research aspects as well. That will get funded separately from this initiative. Those will continue to get funded on other initiatives.
Funded. Thank you.
Are there any further questions?
Well, if you don't have any more questions, we'll wrap up. Thank you for coming, and I'm sure if you have any more questions, you can find us around the conference in the next 2 days, so feel free to stop us and ask us questions. Thank you for coming.